In double linked list, yesterday we discussed how to add the data. That means add at the beginning we discussed. Add at begin we discussed, and how to print the data we discussed, right? So today we'll see how to add a record. That means at the end position we'll discuss now. How to add the data at the end position. Now try to analyze here, all of you. Here head pointer is there. Head pointer pointing to 0. First you created one record, that is A. So roll number is 10. A next is 0. Why? Because there is no records are there. Head pointer will change A. All of you know about this. Same like single linked list one. And here double linked list means A previous node also you need to write it as a 0. A previous is 0, A next is 0, and here head pointer is modified. Then next, whenever one more record is added at the last position, why? Because it is added end logic. At last, whenever you added the record, now you know that this is the modification you need to do. B next address 0. Why? Because there is no nodes are there. B previous node should be A. Why? Because before B, A is there. And after that, A next address you need to modify as a B. These are the 3 modifications you need to do. Head pointer will modify only first case. In remaining cases, head pointer will not change. Only first case, that means head pointer 0. Head pointer will modify. Remaining all the cases, head pointer will not change. This is the record C. Whenever you created, then what will happen? C next address will be 0, you will get. C previous record B is there. B next address is C is there. These are the some cases you need to take care to create a records. We'll go for step by step and we'll check it, how it is going to work and all these things. And you need to find out which node is the last node. Last next address is 0 means that is the last node. Last next address you need to update and a newly created node address you need to update. Am I clear? So you need to write like this. We'll see now the program related to this. So I'm going for a add related. So add.c file I will open. So in this add.c file, now we'll see here added middle wide add end. So this is the logic I am writing here. So whenever you are writing here, try to analyze starting head pointer is global. Head pointer is global and it is pointing to the location, 0th location it is holding. First, you need to create a memory and one pointer new is a pointer should point to this memory. It is having 3 fields. Now you need to scan the data immediately. First, we'll complete this task. So here I'm taking a DLL star new equal to, here I'm taking a malloc size of DLL. Then after that typecasting, if you want you can do it, otherwise not required. After that immediately we need to scan the data, printf, enter roll number, name and marks, scanf, %LD, %LS, %LF, address of new arrow roll number, new arrow name, address of new arrow marks. So these are the things we scanned the data successfully. After that, we need to fill the addresses. First, the task is you need to fill newly created nodes. Am I clear? So now here, if you observe, first we need to fill newly created node addresses. We need to fill. First, we need to fill newly created node addresses. That means new is a pointer pointing to the first position. Now, can you tell me new next what you will get? Can you please let me know what is the new next you will get? In this case, as of now. As of now, new next is what? 0. That means you can write directly 0, you can write it. New previous, can you tell me what you will get? As of now, new previous also 0. Very good. And head pointer you need to change. Head PTR equal to newly created node. These three things should happen whenever head pointer is 0. Head PTR equal to 0. Why? Because here this is the first node. Head pointer is going to change in this case. So you need to take care here 0 and here 0. Here A will come. So record is created. Now second time whenever you called, you are going to create at the last position. Assume already it is available. Now you can see. For understanding purpose, I am taking like this. 20. We can use calc function to decrease the steps. You can use. If you are writing calc function, these two lines not required. These two lines not required. If you are using calc, why? Because initially it will initialize with 0. So these two things you can remove. Better calc you can use it, but some of students are saying that we are not aware of calc. So that's why I'm going for malloc only. Let's move forward, no problem. If you are interested, you can go for calc. So now try to analyze here. Now, whenever you call, one record is created, assume C. C is a record I created. This is a new is a pointer pointing here. Now, if you observe, first I am scanning the data. Whenever I'm scanning the data, you can observe here, I'm scanning some information 30, then head pointer I'm checking, head pointer is A equal to 0 condition fails, it is coming to the else part. Whenever it is coming to the else part, here I don't know which node is the last node. Why? Because I'm going to add at the last position. Yes or no? I'm going to add at the last position. I don't know which node is the last node. So for that purpose, I'm taking one pointer. All of you know this single linked list I already taken like this. Last equal to head pointer. It is pointing. Always pointing to first node. Whenever it is pointing to the first node, now declare here pointer star last. Now you can observe here. It is in this case, if head PTR is 0, head pointer is 0 in this case. Here, if head PTR is not 0, then it will come here. Now you need to find out which node is the last node. You need to find out first. Then only you can update. So I'm going for while of last next. Last next means last is a pointer pointing to the position A. A next address, what is there? Last is pointing here. Last next address I am checking. That is B. B means valid address. That means that is A is not the last node. So I'm going to update here last equal to last next. Last equal to last next. Last next means last next B is there. So now last is a pointer. It is updated to the location that is last. That is B. Again, because of while loop, last next, B next, what is that? 0. while of 0 condition fail. Here next address 0 means you can confirm that this is the last node. This is the last node you can confirm. Whenever you are confirming this is the last node, now you need to update. What are the modifications you need to do? First, you need to fill newly created node. New next address, what you will get? New next, always you will get 0. Why? Because you are going to add at the last position. You are going to add at the last position. So new next, always you will get 0. Can you tell me new previous, what you will get? All of you, please let me know. New previous address, what you will get? B. B means what I need to write here. Statement what I need to write. New previous means what is the statement I need to write? Last. Last or last next? Last. Why? Because last is a pointer pointing to location B. Last is a pointer you need to write. Then whenever you return here, so here what will happen? It is updated B. Now how can you update B next? How can you update B next? Can you tell me the statement? I need to update B next. You need to write last next equal to last next. Last means B. B next address new. You need to write. Last next equal to new. That means last is pointing to B position. B next address is what? 0 is there. Here you are updating as a new. That means C, updated. Am I clear? So this is the way you need to write add it end logic. Now printing is common. Already we printed. Now we'll see VI header file I'm taking. So here update void add end. Am I clear? Any doubt in this? So one of your friends said, sir, repeat line number 33 and 34. One of your friends said, repeat 33 and 34. Okay. Sir, please try to analyze here. Whenever you call the function, assume D is a record is created. Once D is a record is created, now you can observe here, new is a pointer pointing here. Whenever new is a pointer pointing here, first you need to scan the data. We scanned the data successfully. We are checking the condition, if condition, head pointer is pointing to A equal to 0. That means condition fail, head pointer is not 0 means it will come to the else part. I need to add this D record at the last position, but I don't know which node is the last position. For that I am finding. Last is a pointer I am taking pointing to head pointer. Here it is pointing last. Whenever it is pointing here, I am checking last next 0 is there or not. Here B is there. B means valid address. So this is not the last record. So I am updating last equal to last next. So last is a pointer. It is updated to next position here. Am I clear? Once it is updated to B, again I am checking the condition. B next what is there? B next C is there. Valid address is there. That means it is not the last record. So again I am updating last to last next. So here last is a pointer pointing to what? Last is a pointer pointing to next position. That is here it is pointing. Whenever it is pointing here, because of while loop last next. Now you can observe here last next 0 is there. 0 is nothing but what? Now this is the last record. After that there is no records are there. Now you need to add here. So new next line number 32 you can see new next 0. That means newly created node next address 0. Why? Because there are no records are there further. Line number 33, please try to analyze all of you. New previous. Here you need to get the C address. C, how can you write? Last is a pointer pointing to C address previously. Yes or no? V4. You can observe here Last is a pointer pointing to C. So that C you need to write it here. That's why new previous equal to last. That means here it is updated. C link is created. One link is created. Now double link you need to create. Double link list means see if next address 0 is there. You need to update that. Last is the pointer pointing to C. Last next is nothing but here. So new means here you are updating as the D. So whenever you updated, this link also created. Any doubt? Is there any doubt in this, all of you? Now, we'll check it. Our code is successful or not, we'll check. So for that, what I am doing, I'm going for file. I need to call the vi add.c. So here, sorry, not add, vi main.c. You need to update the case. We need to update the cases to add it and break. Add it and break. Now you can see make compiling, main is modified, add is modified, and only two files are modified, print is modified. Sorry, not modified. I deleted actually yesterday. Yesterday .wav files deleted. So now you can see make is up to date. /a.out. Sorry, /exe. So now you can see I'm going for 4. There is no records are there. 2. 2 means enter 12. Hello 12.3. Again 2. 13. High 34.5. Again 2. 18.9. Good 45.5. Again to 90 by 45.6. Now you can see the records are going to add at the end position. So first 12, 13, 18, and 90. This is the reverse direction it is printed. So our program is correct. Am I clear? So next. Any doubt in this? So now try to analyze here. Case number 5, will you try? Case 5, will you try? Count node, counting the records, will you try or not? Nothing is there, just you need to increment the count. Count is a variable you need to take and you need to increment. Assignment. Case number 6, save the data in a file. Save file. You need to open a file and you need to store the data. All of you know about it. Already I discussed in single linked list. So same thing, assignment. Case 7, reverse print. Will you try? Reverse print. Already I discussed in print function. Already case number 4, if you observe, we are printing reversely. Already I discussed it. Just you need to do copy paste and you need to analyze how I am doing. Yes or no? Case number 7. Already I discussed in case number 4. You can observe here. Did you observe or not here? You can see whenever you are going for make, then /a./exe, you can see to hello 12.12, hello 12.3, to 13 high. You can see here whenever I given 4, you can see reverse direction. It is already printing. Already it is printing. That means you need to go for this and you need to implement this one. This one you need to implement. Am I clear? Already reverse direction we discussed. So that's why I given a case number 7 is assignment I given. Next, case number 9, logic is same, single linked list logic only you need to write. Print a recursion. This is assignment. Case number 10 also assignment only. Reverse recursion. Same logic, single linked list, same logic. Why? Because we are not modifying anything, just we are printing already discussed in single linked list. Copy paste same logic, it will work. Case number 11, sorting the data. This is also, we are not modifying anything, just we are modifying the data. Data modification, same thing for if you are going for single linked list, double linked list, circular linked list, the data is same. So you need to go for sort data function, copy paste single linked list logic. Case number 12, read the data from the file. Same single linked list logic only write it. Not single linked list logic. So you need to add it middle or add it end logic, write it. Am I clear? Now, next you can say, we'll discuss case number 3, how to add the data in the middle position. Case 3, add middle. Add middle we are discussing. Wide, add middle. So you can observe here add middle. Add middle in the sense, what we need to do, we need to write the logic in such a way that any position you can add it. So assume first a head pointer is there, pointing to 0. All of you know about this. If I taken one record A, so now you need to take, all of you please listen. A next address right now 0, A previous 0, head pointer is modified. Assume roll number is 10. If I'm taking one more record, that is B record if I'm taking. If roll number is 5, compared to this head pointer, if it is less, then B next address A will come. Starting position, added begin logic. B previous is 0, A previous is B, then head pointer will be modified. Did you observe or not? Here head pointer is modified in 2 situations. Same like single linked list, head pointer is modified in 2 situations. One is if the record is having 0, one is roll number of head pointer is compared to newly created roll number greater. These are the 2 situations the head pointer will change. Next, if you observe, if you added the record C, then what will happen? New next will be 0 and roll number 20 means at the last position, C previous is A previous will be C will come. If you added one more record D in the middle position, then what will happen? This roll number is 15. That means in between 10 and 20, you need to add D next address is C, then C previous address is A next is D, C next is D. Like this, you need to modify. So all these things we need to take care. Am I clear? So first you need to take create memory. Then after that, second thing is head pointer, scan the data. Scan the data. After scanning the data, third point is what? Head pointer will modify 2 situations. One is if it is 0. Second is new roll number is less than head roll number. Then after that, fourth one, record may add at end or middle. Am I clear? These are the things we need to take care. So how we are going to taking care or try to analyze? First, I am going to take a head pointer. Head pointer is starting initially pointing to 0. I created one record that is A. New is a pointer pointing here. So I need to scan the data. The data is 10. First, we'll try to complete up to here. Up to this will complete. So here you can see DLL star new is a pointer. New equal to then DLL star malloc size of DLL memory is created. After that, immediately our task is we need to scan the data, enter roll number, name and marks. We need to scan immediately. Scanf %LD address of new arrow roll number, new arrow name, address of new arrow marks. These are the things we scanned successfully. After scanning, you know that head pointer will modify into situation. So first situation will take care. If head PTR equal to 0, yes, head pointer is 0. So I need to modify new next equal to newly created node next address. Either you can write 0 or you can write head PTR, you can write it. Either 0 or you can write head PTR, you can write it. Yes or no? I hope you clear this point. Any doubt in this? New next equal to 0 or head pointer. So directly you can write 0 or head pointer is pointing to 0, you can write it. New previous address you need to take. New previous address. Newly created node previous address equal to 0 or head PTR. Anything you can write it. So here also what I'm doing, newly created node previous address 0. After that, there is no records to update. Finally, head pointer you need to update. So head PTR equal to newly created node. Any doubt in this? Can you let me know, please? Sir or madams, do you have any doubts related to this? These three statements? No. Okay, fine. Now try to analyze. One case is modified. Second case we'll try. Second case, head pointer will change when means whenever newly record is created, new record is created, this new record is going to hold the roll number compared to head pointer is less. That means here I'm taking roll number is 5. Newly roll number is compared to head pointer, this is less. So now head pointer will change. Now you can see I need to check one more condition here. If head pointer is 0, it is not 0. Or you need to take one more condition. New roll number, newly created roll number is less than head PTR roll number. Head PTR roll number. In this situation also, head pointer will change. So now tell me, new next what you will get. What is the statement I need to write? New next. New is a node, it is pointing to B. New next, what is the pointer you will get? What is the address will get? A. A means I need to write 0 or head pointer. In this case, I need to write head pointer. Yes or no? Head pointer, whenever I am writing, head pointer is pointing to A, so it is updated. One link is created successfully. Now new previous, can you tell me? New previous, what you will get? B previous 0. That means head pointer is not the correct condition. So you need to remove this head pointer. So only 0 will come. Why? Because there is no records before B. So here 0 will come. Now here you can observe, I need to update head pointer, or is there any other modifications are there? I need to modify head pointer, or is there any other modifications? Very good. You need to modify A previous. This A previous address you need to modify. A previous address, how will you modify? Means here head pointer, if you observe, still pointing to the position A. Head pointer is not updated. Head pointer still pointing to A. So here you need to write a head PTR previous address equal to newly created node you need to write. Head PTR means still pointing to A. A previous means here. New means it is updated as a B. Link is created. When this statement should execute? Whenever head pointer is not 0. If head PTR not equal to 0, then only this extra statements you need to write. Otherwise, not required. Any doubt? Do you have any doubt in this? Any doubt? Next. Now try to analyze. I'm moving forward. So I'm going to add the record that is going to add at the last position. C is the record. I'm scanning the roll number is 20. Compared to all these things, the 20 is greater. So you need to add at the last position. So I don't know which exactly position I need to add. So I'm going for else part. In the else part, I'm taking one pointer. Last is a pointer. It is pointing to head PTR starting road. Always holding first node address. Whenever it is holding first node address, I need to check while last is pointing to the position that is nothing but what? You can observe here. This is last is pointing to the first position. New is a pointer pointing to the C position. Now we need to check. Already here 5 is compared with 20 we are checking. Why? Because here if you observe head pointer is how much? 0. A equal to 0 condition fail. New roll number is how much? New roll number is 20. Less than head PTR roll number is 5. Condition fail. It is coming to the else part. Already 5 is compared with 20. So you need to compare with the next node. You need to compare. For that, what we are writing? We are going for the statement while of last next roll number. While of last next. Last next means B next A. A roll number how much? A roll number is 10. 10 is less than. 10 is less than newly created roll number or not. I am checking. Just 10 is less than 20. That means this is not the position you are going to add. This is not the position you are going to add. That means after B you are not adding. After B you are not adding. So maybe you need to update. So here I'm writing last equal to last next. Same like single linked list only. Same like single linked list. Last equal to last next. Now last is a pointer pointing to the position. A position it is pointing. Whenever it is pointing, because of the loop, again it is coming last next, A next 0 is there. After that, there is no record, but still you are finding the roll number, you will get segmentation fault. For that, you need to check one condition you need to check. What is the condition you need to check? Last next is not equal to 0. And with you need to check like this. Now, if you observe last next is what? Last next is A next 0. 0 not equal to 0 condition fail. while loop is failed. That means here is the position you are going to add. After A, you are going to add. So whenever you are going to add after A, then what will happen now? You can observe here. I need to first take care about the new node. So, and how many modifications I need to do, you can observe here. I need to do the modification. This is one modification. This is second modification. This is third modification. These are the three modifications you need to do. Total three modification. First, I need to fill newly created node. So new next address, new next equal to, you can write it directly 0, or you can write last is pointing to A, last next also you can write it as of now. You can write say next address 0 will get, or last next also 0 is there, you can copy. That means here you are going to copy 0, you are going to copy. Is there any doubt in this? Line number 60, do you have any doubt? Line number 60, do you have any doubt? New is pointing to C, C next address I am modifying, last is pointing to A next means A next address 0 is there, it is copied. A next address is copied. Then after that, I need to fill new previous. So here I need to write newly created node previous address equal to. Can you tell me what you will get? New previous. Newly created previous address. New previous is A. A means A is available at the last position. Last. Yes or no? New previous equal to last. Last is a pointer still pointing to the position A. So now you need to write here what? A, you need to write it. Link is created. Two modifications completed. Third modification, last next you need to modify. So here you need to write the condition last next address equal to newly created node. Last next equal to newly created node means here you will get C is the position you will get. Am I clear? Last next equal to new. Now created successfully. Now assume you are going to create again one more record you are going to create. Whenever you are going to create one record, now please try to analyze what are the modifications you need to do. Now total 3 modifications we did. But whenever you created one record D in the middle position, I'm scanning the number is 15. So what are the modifications I need to do means this is 1, new next, newly created next address 1, previous address 2, this C before it is adding. So this is the one position you need to modify. A next you are modifying. So this is the position you need to modify. That means if it is added at the last position, 3 modifications. If it is added in the middle position, total 4 modifications is there. Now you can see. First, I am checking head pointer A equal to 0, it is failed. Newly created roll number is 15. Head pointer roll number is 5. Head pointer roll number is what? 5. Condition is failed. It is coming to the else part. Last is the pointer pointing to the position B. I'm going to check which position exactly I'm modifying. Last next, B next is what? A address is there. A not equal to 0, condition true, yes. So I'm checking the next position. Last next, last is B. B next address is A. A roll number is 10. 10 is less than 15 means the condition true. This is not the position you are adding. This D record, newly created node, you are not adding after B. So it is updated to last equal to last next means last is a pointer pointing to the next position. That is nothing but what? It is pointing to the position, A position it is pointing. Again, while loop, last next, A next what? C. C not equal to 0, condition true. Whenever the condition is true, it is checking for next one. You can see C next, that is what? 20. 20 is less than 15, condition fail. That means this is the position you are going to add. Now, after A, you are going to add the record. That means it will come outside. you can see new next here, newly created node next address. Can you tell me what you will get? Newly created node next address. Can you please let me know what you will get? Zero. How zero will come? It is adding in between C. Before C, it is adding. So you will get C. C is nothing but last next. It is not getting zero. Am I clear? Before. Last next. Last next means last is pointing to the position A. A next address C. This C will come here. Link is created. Link is created. Am I clear? Line number 60. Is there any doubt? New next equal to this one, newly created node created. New previous equal to last. Previous here, last means A. Link is created. Line number 61. Newly created node previous address last means link is created here. Now, next you need to modify this. This you need to modify. This if you need to modify. Now, before updating the last, now you can observe here what I am writing. I am writing newly created node, next address, line number 62, try to analyze. New next, can you tell me what is the new next is there? New next, what is there? C. Now we need to update C previous address. So again, arrow previous. That means now you can observe new next is C. C previous means this is the position. This is the position we are updating. Here, what is the node will come? Here, newly created node will get. Here you will get newly created node. That is nothing but the position you will get. That is nothing but what? Here is the D will get. That means here double linked list is created. Double linked list is created. Then after that, you can see last next equal to new. Last is this one. Next here, you are going to create a new. That means D link is created. Double linked list. But if you observe line number 62, fourth statement extra it is adding. When means if last next not equal to 0. If last next address you need to take care. Last next not equal to 0, then only you need to take care this. Am I clear? If last next address 0 is there, then no need to do any modification. But last next, whenever 0 is there, then you need to take care about these modifications you need to take care. I hope you clear this point. Last next 0 is there, then no need to update that. Last next still some addresses are there. You are going to add in the middle position. Then this statement you need to add. That is line number 63 will come. Now we'll check it. Vi add.c. Sorry, vi main.c. So already added. Now you can see make is a command I'm executing. Header file I need to update. Last is a pointer I didn't update it. So here you need to create. Last is the pointer you need to create. Then after that, am I clear? So here I'm going to update the head pointer. So here I'm going to write a void add middle. So you can see make a compile ./exe. Now first 4 no records are there. 3, 12, hello 12.3, again 3, 2, high 34.5, again 3, 89, bye, again 3, 1, good, again 3, 56. So the data will be coming order, sorting order. You can see 1, 2, 12, 56, 89, 89, 56, 12 to 1 coming in the order. Am I clear? So now just to analyze this task, I will come within 2 minutes. So analyze this add it middle. If you have any doubt, you can write it in chat box, or you can raise the hand. I will be back and I will explain this. Check it. This any doubt do you have or not? These are the statements. If you have any doubt, you can ask me. I will be silent for 2 minutes. Just a second. Just analyze the code. One of your friend asked one question. Sir, can you explain line number 43 to 49? This line number 43 to 49, the head pointer is going to change. Your head pointer is going to change in two situations. One is if head pointer starting, if it is 0, there is no records are there. Starting, I added one record A. Now, if you observe there is no records are there, first record I'm going to add. In this case, you can say 0 equal to 0, condition is true. It is entered. R operation first condition true, it will not check second one. This is newly created node. Now you can see line number 45, new next equal to head pointer means here 0 is there. Why? Because head pointer pointing to 0. This 0 I copied here. New previous equal to 0 means directly I added 0. Why? Because first record, previous address always 0. Then after that I'm checking head pointer is not 0. So here 0 not equal to 0 condition failed. There is no records are there. That's why I'm not updating this one. Head pointer equal to new means it is pointing to A. Link is created. Now you can observe here all the statements are working successfully. Next, if I am trying to add one record before A. Now new is a pointer pointing here. Then after that here, if you observe 5, if I am taking, then you can observe here. Now try to analyze here. Whenever you are going for this newly created node, first you can see this head pointer. Head pointer is what? A equal to 0 condition is failed. That means still some records are there. It is not the first record. So I'm going to check newly created roll number. New roll number, how much? 5, recently created. Head pointer already pointing to A record is 10, condition is true. If condition is true, then what will happen? It will enter into this new next equal to head pointer. Newly created node, next address head pointer means A. Definitely it will come A only. Link is created. New previous equal to 0 means now you are creating as the first record. So here 0 will come. Head pointer not equal to 0. Head pointer means here head pointer is a not equal to 0. Condition is true. That means head pointer previous. Head pointer pointing to a, still you can see link is available here. It is pointing to a previous address. Here you are updating as a newly created node. That means B. Double link is created. Double link is created. Then after that head pointer equal to new. That means it is pointing to B. Link is gone and it is pointing to newly created one. You can see head pointer pointing to B. B next is A next is 0. A previous address is B. B previous address is 0. Am I clear? One of your friend asked, sir, explain now 15.7 to 61. One person asked this part, one person asked this one. Now you can observe here. Try to analyze. Now you can observe here. These are the records are there. Now you can see here, there is some records are there. You can observe here. Now I am going to explain line number 53 to 61. I am explaining. Listen. So I created one record. That is the record is D. Last record I created. Whenever I created last record, this is the new is a pointer pointing here. I scanned the roll number is 30. I need to add which position according to us C next will come. If you see in the diagram, C next will come. Programmatically, we need to check where we need to add. So I don't know where it needs to add. So first I'm checking A equal to 0. Condition is fail. New roll number, newly created roll number is 30. Less than head pointer roll number is 5. Condition is fail. So it will come to the else part. Last is the pointer pointing to first node. Here it is pointing. I'm checking last next any address are there. A next there are some addresses are there. I'm checking. A next B is there. B not equal to 0. Condition true. Yes. Records are there. So I'm checking last next roll number. Last is A. A next is B is there. B roll number if you observe 10. 10 less than newly created roll number 30. That means condition true. That means you are not adding after A. You are not adding after A. So you are going to update last is a pointer pointing to next node we are changing. So here what will happen? Last is pointing to this particular position. Because of loop, last next B next C is a valid address is there. C next roll number, sorry, B next roll number, B next C is there. C roll number 20, 20 less than 30. Condition true. That means after B you are not adding. It is updated to last next. That means last is a pointer pointing to next position, that is C. Last next not equal to 0. Last next there is no records are there. No need to check the roll number. 0 not equal to 0. Condition fail. It is coming outside. New next. Newly created node next address. Last next means this 0 I copied. New previous equal to last means here you are updating last. Last is pointing to C. It is updated. One link is created. Last next means 0 is there. That means further records are there. So it is not updated. Last next equal to new means here you updated D. Double link is created. Double link is created. Now try to analyze. You are going to add the data in the middle position. Whenever you are going to add the data in the middle position, you can observe here what we are going to do. Roll number is 25. Whenever you add a 25, you can say last next. So these conditions will be fail. Last is a pointer. Here it is pointing. You can see last next some address is there. B not equal to 0. Condition true. It is checking the next node. A next B is there. B roll number is 10. 10 is less than 25, condition is true, so it is not after A, so you are updated last is the pointer pointing to the position B, it is pointing. Whenever it is pointing to B, because of loop, we are checking the condition again. B next is valid address is there or not. Yes, valid address C not equal to 0, condition true. Now you are checking last next C. C roll number how much? 20. 20 less than 25. Again condition true. That means after B also you are not adding. So it is updated to next position. Last is pointing to the position C. Whenever you observe next, now because of loop last next not equal to 0, that means C next D is there. D is a valid address, D not equal to 0, condition true. But if you observe here this statement, last next is D, D roll number is 30, 30 less than 25, condition fail. This is failed. Now this is failed means it is coming outside. Now you can say new next address. This is the newly created node. Next address is D will come. That is available in last next D is updated. One link is created. New previous equal to last means here last is pointing to C. This is side one link is created. Now I need to update last next D valid address is there, D not equal to 0, condition not true. So newly created node next address is D. D previous address here you are updating new means E record is created, double link is created here. Last next equal to new means here you updated E, that means here also double link is created. Here also double link is created. Now you can observe here in this diagrams, if you observe, you can see here A next address B, B next C, C next E, E next D, D next 0. D previous address you can see E is there, E previous address you can see C is there, C previous address you can see B is there, B previous record A is there. Double linked list working successfully. Am I clear? Next. Now we need to delete all the records. Will you try delete all? 8. Delete all. Same like single linked list. Will you try? Or shall I explain? Check it. Case 8. Delete all. Delete all you can observe here. Header file. Void. Delete all. Now we need to create one file. Delete.c. Header.h. Now you can say void delete all records. If you observe here, header pointer is pointing to A. A next address is B, previous address 0. B next address is C, A. C next address is 0, here B is there. Now I need to delete all the records. First I'm starting from here. If I need to delete this, then I need to update head pointer to this position I need to update. Then only you can delete this. So I'm taking first checking one condition. If head PTR equal to 0, then directly you can say printf no records available to delete. Return. If records are available, I'm taking one pointer. Del is a pointer pointing to first record, head pointer, holding first node address. Whenever it is holding first node address, if I need to delete that, then I need to rotate a loop. Why? Because all the records we are deleting, not one record. So now I need to update head pointer. Head PTR equal to head PTR next address. Head PTR next address means now you can see head pointer is pointing to B record. A next to B is there. Whenever A head pointer pointing to B, now this is independent. Now you can delete this. How can you delete means by using free function, you are going to delete free of del. Free of del you are writing. Whenever you updated free of del, now it is deleted. This record is deleted. Anyhow, you are deleting all the records, so no need to update this B previous. As per the standard, if you need to write, you can write it. But anyhow, you are deleting all the records. B previous, no need to update. So I am taking one pointer del. Del is pointing to the head PTR. It is pointing. Now del is a pointer. If you observe, it is pointing to the position here. If I need to delete this, then I need to update head pointer. So because of the loop, head PTR equal to head PTR next. That means it is pointing to C. Here it is pointing C record, it is pointing. Whenever head pointer pointing to C, it is individual now. So free of del means it is deleted. Then del equal to head pointer means del is pointing to here. Then before deleting this, you can say because of loop head is the head next means here it is 0 updated. Head pointer is not pointing to anyone 0. Then free of del means it is deleted. Then after that del is pointing to 0. While of 0 condition fail, loop is terminated. Am I clear? So one of your friend asked one question, sir, please explain why we are not taking arguments to functions. Why there is no formal arguments are there? Why formal arguments? Head pointer is global. Global means directly you can access. Now, what is the requirement of passing head pointer? Am I clear? I hope you clear this point. Why formal arguments are not there? Why formal arguments not there means head pointer is global. Global means directly you can access. In the single linked list, I discussed with local pointer, but here this is global pointer. Because of that reason, we are not taking this. So here, if you observe, deleting the memory. So here, updating head pointer to next node. Next, holding next node address. Next node address. Clear? Now you can see make undefined reference. Okay. In main function, we didn't use to delete all, but we are using delete, delete all, break. Vi delete. Okay. In this make file, we didn't add a new file. We need to add new file. Delete dot o, delete dot c, cc hyphen c, delete dot c hyphen o, delete dot o. So here you need to add delete dot o. Here delete dot o. Make. So delete file also compiled. ./exe. Now you can see 1, 12 hello, 12.3, 1, 13 hi, 1, 67, 1 is 68, You can observe here total 4 records are there. I'm going to give the option number is how much? 8. Delete all. So all the records deleted. You can see no records are found. All the records deleted. So that's why there is no records are found here. Am I clear? Now you can see this reverse data is very easy. Will you try that? Reverse the data is very easy. Why? Because here you can observe here. So whenever head pointer is pointing, head PTR is pointing to A record. So here you can see A next is B, B next is what? C is there. Then you can see C next to D is there, D next to 0 is there. Here 10, here what is there? C is there. Here 20, and here B is there. Here 30, here A is there. Here 40, here 0 is there. Now first what you need to do, you need to take one pointer P1 here and make one pointer at the last position P2. After finding the count, 1, 2, 3. 3 times if you rotate, then it will point to P2. Am I clear? I hope. Last node next. How can you write last node is not there here? So what you need to do, you need to take one counter for I equal to 0, I less than C, I plus plus. Then here you need to write last is a pointer, last equal to last next. Or P2 take it, P2 next. P2 is a pointer, P2 equal to P2 next whenever you are taking. You can see P2 is pointing to D position, P1 is pointing to here. Now what you need to do, you need to swap the data. After swapping the data, write it P1 equal to P1 next. P1 next means it is pointing here. P1 is a record pointing to B position. You need to write P2 equal to P2 previous. This is double linked list. You can travel reverse direction. P2 previous means it will come to here. But in single linked list, every time you are coming from the starting position, but here no need to come from the starting. Previous means it will come to B position. Swap these two. Whenever P1 equal to P1 next means P1 is pointing to next position C, P2 is pointing to the position that is B. But for loop is rotating only 2 times. Why? Because total 4 records are there. Loop is rotating only 2 times. So what will happen? It will stop the program. Am I clear? Any doubt in this? You need to take first count, first pointer, make it first position, next second pointer pointing to the last position. Then pointer P1 equal to P1 next means next position. P2 equal to P2 previous means it will come to the previous position. In single linked list, every time we are coming from the starting position, but here we are coming in the reverse direction only. Why? Because double linked list, both directions you can travel. Any doubts related to this? So don't think that I'm giving more assignments. These are similar. So that's why I'm giving. And if you are practicing, then definitely you will come to know. If you are not getting, then come and meet me. I will be available in office 225. So I will be available in ground floor. Maybe I cannot come to lab, but I am coming to the lab every day. So only few members, 5 to 6 members practicing, and different batches also is there. But BE5 only 5 members is there whenever I'm coming to the lab. But some students personally they are coming down and they are asking the doubts. Okay. So if you have any doubt, you can come to the ground floor and you can ask the doubt. And if a big problem is there, then I will come to the lab and I will open your code in your system and I will check and I will let you know what is the problem exactly you are facing. I hope you cleared this point. So here, reverse data. This is your assignment. Next, now here, if you observe, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. In this 14 and 15, I will discuss one program. 16th, I will discuss. Don't worry. Reverse links, I will discuss. In this two, which one I need to explain and which one you will try. 14 and 15, I will explain only one thing. So which one you will try? Delete node or delete position. Which one you will try? Which one I need to explain? 15th one you will try or I need to explain? 15th, okay. So 15th you will try. Everyone is saying, okay, fine, good. Deleting node according to name, that is always assignment. Okay. Delete a node according to name is the assignment. Okay. You can try just instead of if condition roll number, you need to check with the name. Try from your side. If you are not getting, come and meet me in office. I will explain. Okay. First try from your side. Definitely, I will support you if you are trying. So definitely I will support. I will be available in office. So definitely I will support. So come and meet me in office. Those who are facing deleting according to the name. Am I clear? Okay. From my side, I'm going to give delete roll number also try. Delete roll number. Case 14 also try. Delete node according to roll number name marks try. This is also assignment. 15th and 16th I will explain. 16th one and 15th one I will explain. These two in tomorrow's class I will explain. So tomorrow we'll see. Tomorrow we are going to explain this 15 and 16 and we'll close the session of this, what is that? Double linked list by tomorrow. Tomorrow we'll close double linked list and we'll start circular linked list will start. If you have any doubt, you can ask or else you can close the session from your side.